So we're gonna first start off with adding and subtracting the radicals. Last time we learned how to multiply and divide radicals. We're gonna add and subtract. Now, two things to keep in mind is something like this. If I have a simple expression like 2x plus 3x plus 6y, is there a way to simplify this?
Yes.
Yeah, who can tell me what the answer is? Yeah. 5, what did you say? Factor, what can you factor?
Oh.
Yeah, you probably don't want to factor. Anybody know what to do? Yes?
You just add the x's.
Add the x's. What's the answer, Sherry? 5x plus 6y is correct. Now, why is it that I could add 2x plus 3x, not 6y with 2 and 3x? Yeah.
Because they have the same verb.
They have the same verb. Not only because they have the same verb, they are like terms, aren't they? Right? When you have like terms, you could gather them together. What property tells you that you could gather 2x and 3x? No? Yeah. The distributive property, you guys remember this? The distributive property tells you that you could add 2x and 3x, not 6x. Right? You guys remember? Yeah, a lot of you know this as gathering the like terms, but really, if you really think about it, how is it that you could gather the like terms? It's because of the distributive property. You guys remember this? So if you know how to do this, okay, you could do the rest for tonight, for 11.8, because it's the same idea. Can we add 5x and 6y? No, of course not. That's why. Okay, so now what if I give you something like this? So instead of x's, I now have square roots. Okay, so I got 8 rad 11 plus 2 rad 11. Now knowing what we just learned, so we just saw it here, how do we simplify this? Yeah.
You add the numbers.
Yeah, you add the 8 and 2 times rad 11 because we're going to use again what property? Distributive property. Okay, so if you don't want to get it wrong, write this work, right? Because it's really the same thing as thinking about it as 8x plus 2x, isn't that right? Do you understand? So sometimes people write this as 10 rad, I don't know, 11 times 11 or something, or 22. Can I write 10 rad 22? No, you don't add the ones in the radical, right? It's just like x. Does that make sense? We're using the distributive property. You see why it's important to understand the algebraic property here? Otherwise, people just follow the rules and get it wrong, right? They add 8 and 2 and 11 and 11. That's totally wrong, okay? Right? You have to really understand that we're using the distributive property when you're gathering the like terms, right? Any question? Okay, so what about then this one? 7 rad 3 plus 2 rad 2 minus 3 rad 2 minus rad 3. This is a little bit different because not all the radicals are the same, are they? So what should we do? One person? Oh, you guys need more time? Okay, I'll give you some more time. Chris, what should I do?
Combine the like terms.
Yeah, in other words, yeah, so which one should we combine them? Yeah.
7 rad 3.
Yeah?
And subtract it with negative rad 3.
Yeah, and then the ones in the middle, 2 of them, right? Now, what property am I using when I'm changing the order? Commutative property of addition. So do you think it's best to write it as an addition? Yeah, because otherwise you can't really move it around, can you? Right, there is no commutative property of subtraction, is there? So I wrote everything as addition. Is that okay? Right? Who could tell me then what I get when so I even wrote the invisible one here, right? Now let's use now we look gather the like term, but really we're using again the distributive property. Will, tell me what to write.
You get 7 minus 1 in parentheses times rad 3.
Uh-huh.
And plus 2 minus 3 in parentheses rad 2.
That's right. Okay. So we get here, did you all write down 6 rad 3 plus negative 1 rad 2? Okay, of course, this is the same as what, guys? 6 rad 3 minus rad 2. Can we go any further? Oh, sorry. Could we go any further? No? Is that it? Yeah, there you go. Okay, that's all you could do, right? Any question? Just pretty easy. Yeah, okay, pretty easy. Now, what if I give you this? 25 rad 2 plus 2 rad 27 minus 3 rad 98. Okay, write it down. Well, it kind of looks like there isn't any like term, right? You can't really use the distributive property, can you? So we're done, right?
No.
We're not?
No.
Why not, Sam? Yeah, look at square root of 27 and square root of 98. They contain a perfect square as its factor. So guess what? We have to first do, before we do anything, first simplify. Always what? Simplify. So do a factor tree for 27 and 98, right? You will see that they contain a perfect square, right, guys? So go ahead, everybody. So I did 27 and 98. I could already. Does anybody see the perfect square for 9? Which factor? Which perfect square does 27 have? 9, and what about 98? 49, right? When you divide by 2. So you get 3 times 3 times 3 is 27. 2 times 7 times 7 is 98, right? Okay, who could tell me then how to simplify these radicals before we do anything? So the first term is same, 25 rad 2, plus. How do I rewrite 2 rad 27 as? First of all, what is then square root of 27? That is same as? Hello? Square root of 27 is what? What is square root of 27? Uh-oh. Yeah, 3 square root of 3. What is 98, guys? 7 square root of 2. Hello? Come on, right? You know that. Okay, so then, who can tell me what to write here? You get 25 rad 2 plus what? What is 2 times 3 rad? Yeah.
25 rad 2 plus 6 rad 3.
Good.
Minus 21 rad.
There you go. Okay, did you all get that? All right. So now, could we simplify now? Yeah. So they're like terms, aren't there? So you got 25 rad 2 and negative 21 rad 2. So let me rewrite them using commutative property of addition. Aaron, what did you get?
4 rad 2 plus 6 rad 2.
Yeah, 4 rad 2, because again, you use the distributive property. So you get 4 rad 2 plus 6 rad 3. Pretty simple, right? Any question? Okay, so let me summarize what we just did here. Is that okay? So to simplify sum or difference of square roots. Okay, to simplify sum or differences of square roots. Square root with radicals. Okay, so square root radicals. What's the very first step? Just like in this problem, you should always what? Simplify. So the way they say that is they say express each radicals in simplest form. That's always simplify, right? Then of course you gather your like terms and use the distributive property. So here's what this is how we say it. Use distributive property to add or subtract radicals with like, instead of like terms, guess what they say? Like radicands, right? It makes sense, right? Because they're the like, don't they have to have the like radicands? Right? Just like terms, okay? So write this down. Let me switch your gear a little bit and go into 11.9 now, okay? So I'm gonna combine these two sections together. They're pretty straightforward. 11.9 is about multiplication of binomials containing radicals. Okay? So that's our topic for 11.9. So guess what you're gonna see? You're gonna see some binomials with radicals. Okay, so here's our first example. So how do we multiply this binomial? 6 rad 10 times 6 minus, 6 rad 10 times 6 minus rad 10. 6 plus rad 10, I mean. 6 plus rad 10 times 6 minus rad 10. Anybody remember how to do multiplying binomials? We've dealt with this before, haven't we? How do we multiply binomials? Yeah, you do what? 6 times 6, then what? 6 times negative 10, then you go what? Rad 10 times 6, rad 10 times negative rad 10, right? So you do this. Right, guys? You guys remember this? Go ahead, see what you get. Everybody try. Okay, who can tell me what to write here? Yeah,
Well, if you're going to multiply by 6 first, it's 36 minus 160.
there you go. 36 minus, 36. 6 times 6 is 36. What is 6 times negative rad 10? Negative, no, yeah.
Negative 6 rad 10.
It's just negative 6 rad 10, right? You don't multiply 6 times the radicand, do you? It's just 6 times rad 10, it's just 6 rad 10, right? So, and then, well here, rad 10 times 6, isn't that 6 rad 10 again? this time is positive, then rad 10 times rad 10, what's rad 10 times rad 10? 10, right? Is it negative or positive? Negative. You got positive 10 minus negative 10. So don't you just get 26? This is kind of nice. Look what happened to all the radicals. They disappear. Why?
Because there's a square of
Oh, you first have to square these first and the last term, and then what happens to the middle terms? Will's right. Yeah, they cancel out. Isn't that what happens? Yes? Hello? Have you seen something like this? Have you seen something like this before?
yes.
Remember the difference of squares? If you do a plus b times a minus b, what do you get? A squared minus b squared, right? That's why none of the radicals are here anymore, because if there was, will you be squaring the first and the last term, right? And then all the middle terms with radical, they cancel away, right? Don't they cancel away like that? They all cancel and you don't have any. You guys remember this? Difference of square? Okay, so so try this one now. We've learned difference of square before, haven't we? So you could just square the first term minus, remember it's subtraction here, right? That's the part you got to remember. It's going to be something minus the other, right? The second term. So it's going to be, what goes into the first term? It's going to be something minus, square minus something else square. What goes in here? Rad 7, what goes in here? Yeah, your B now is 5 rad 2, isn't that right? Your A is, right? Rad 7, your B is 5 rad 2. You guys remember this? So, you're just basically squaring the first term, subtract, and then square the second term. Remember? Difference of square. That's why it's called difference of squares. You take the difference of the squares of the first and the last term. Yeah, what would the answer be? What is rad 7 squared? 7. What is 5 rad 2 squared? It's 5 rad 2 times 5 rad 2, which is 5 times 5 is 25. Rad 2 times rad 2 is? What's rad 2 times rad 2, guys? Rad 4, which is 2. So don't you just get this, guys? 7 minus 25 times 2? There you go. So you get negative 43 as your answer. Pretty straightforward, right? So isn't this kind of nice to know the difference of square pattern, right? Which is, again, look at all the square roots. They all are gone, right? You don't have any more. Does that make sense? Any question? Yeah, here, don't you, here, let's look at, we know that square root of 7 times square root of 7, you get 7, right? Minus, this is 5 rad 2 times 5 rad 2, right guys? What's that same as? 5 times 5 and what? Square root of 2 times square root of 2. What's 5 times 5?
25.
What is square root of 2 times square root of 2?
2.
2. Does that make sense? Okay. Now knowing this is why I did all that. Previous example. Example 6. 1 over 5 minus 2 rad 3. And I say simplify. By the way, isn't this already simplified? No. What's wrong with this? Why isn't this simplified? One person's here. 2, 3. Yes, Sean. Why is
there's a radical on the denominator.
That's right. There's a radical in the denominator, rad 3, so that's not good. So, what should we do? How do we deal with, yeah?
Multiply the top and the bottom by rad 3.
Yeah, multiply top and bottom by rad 3, right? Not quite. There's a problem. Let me show you why it's not good. Anybody see already why? Look, what happens if you multiply top and bottom by rad 2? We did that before when you have a monomial on the bottom. Now we have a binomial. What happens if you do this? Yes. Then the 5 will have the radical. You see what I mean? So trying to get rid of radical, yeah, you could get rid of the radical 3 here, but then the radical 3 will be with the 5. Now, then, can I multiply top and bottom by radical 3 again? No, then the other one's going to have radical. Oh, yeah, it's just going to be back and forth. That's not good. Any idea what to do? Hint, hint. Look at what we just did before. In example 4 and 5. Is there a way to get rid of this radical when you got one person's here? 2.
I see it.
3, 4. Raju, what do you think?
Factor the radical out.
Oh, I cannot factor the radical out because the radical 3, rad